What's up, everybody? Hutch here, and we're on lesson 3-3, multiplying integers. So let's go ahead and get into it. Remember, you can use number lines and other mathematical properties to understand and multiply integers. We're going to briefly talk about some of these properties right here. As long as you understand how the mathematics works, remembering the property name isn't as important. But we do want to be familiar with them. All right. So typically you're not going to draw a number line to represent multiplying integers, but I do want you to understand what this means. So if we have 3 times a negative 6, okay, remember that the times can be represented as groups of. So if you think of that as I have 3 groups of negative 6, then again, we're starting at 0, and you can see it makes sense that I have 1 group, 2 groups, 3 groups of negative 6, placing me at negative 18 as a final answer. So that's how that works. If you had a negative in front of here, okay, you can sort of think of the negative as the opposite of. And so you could just take care of this here and do 3 times 6, which would be negative 18. But then opposite of would actually be a positive 18, right? And so that's why when you have a negative times a negative, you actually make a positive, because you're saying the opposite of 3 groups of that negative number. So I just wanted you to be aware of both those situations as we continue. We're going to be using this as the little trick to remember everything. So if you take a look down here, if you love to love, okay, meaning we're multiplying a positive times a positive. If you love loving, then obviously you love at the end. So a positive times a positive is a positive. Okay. If you hate hating, so you hate to hate. Think about that. If you don't like hating, then what does that mean? That means that you love. So multiplying a negative times a negative is also going to be positive. So I want you to notice also the 2 same equal the positive, the 2 same equal the positive. So just a pattern to be aware of. Multiplying positives equals a positive, multiplying negatives equals a positive. Okay. All right. Now, this is the hate section. If you love to hate, you love hating, then obviously you hate. If you hate loving, then you obviously hate. So when you have the opposite operations, they create a negative, okay? Because you're multiplying groups of negatives in both of those situations. Okay. All right, so that's what we're going to focus on as we continue. That's just a trick to help you remember. But this number line is really going to be your visual conceptual understanding for this lesson. So here we go, multiplying integers, different signs. Remember, if there's just a number separated by a parenthesis, then that is multiplication. Okay, unless it's organizational, which we've had some experience with. All right, so look at the signs. It's a negative 7 times a positive 5. So negative, remember, is hate, and positive is love. So if you hate loving, then you actually hate. So put your negative right away, and you have 35 as your answer, okay, as negative. Okay, so I love to hate. Okay, if you love hating, then you hate. And so 9... Where are you, calculator? 9 times 13. Obviously, you could do it on your own, but this is not a multiplication lesson. So 9 times 13 is negative 117, because we have 9 groups of negative 13. So it's obviously going to be a huge negative. Okay, I love to hate. All right, let's multiply integers with different signs. You can see in word problem. So we're talking about ascending and descending again, and things like that. So be aware of what the number would be. A submarine is diving from the surface of the water. It descends. I know descends means subtract, or negative in this case, at a rate of 90 feet per minute. So that's a negative 90 feet per minute. What integer represents the submarine's location in feet after 11 minutes? So let's write our expression. So we have negative 90 feet for a time period of 11 minutes. And so I look at the operations, and we have I hate to love, negative and a positive. If we hate loving, then we hate. We also have 11 groups of negative 90, which is obviously going to end up negative. 11 times 90 negative, okay, you can see is 990 with the negative symbol, okay. All right, helicopter descends. Descending means what? Subtraction, so always label it in the problem. 275 feet per minute, that's negative. What represents the change in altitude in feet after 7 minutes? So let's write our expression, negative 275 minus 7, okay? And, oh, sorry, not minus 7. What are we doing here? We're multiplying for 7 minutes. There we go. That's better. All right, so look at your operations. I have 7 groups of 275, okay, negative 275. We hate to love, okay, so here's my hate, and here's my love. If we hate to love, then that means we hate at the end, so it's going to be negative, so we just do 275 times 7, gets us at 1,925 feet, okay, and it's negative change in altitude. Okay, I need to make sure that we put feet up here as well. Okay, so we don't lose a point if it was a test. All right, so now we have multiplying integers with the same sign. And what I talked to you about that is when multiplying two integers with the same sign, such as 5 and 6 or negative 5 and 6, the sign of the product is always positive. Okay, and I know that's a little bit hard to understand. Obviously, we know that 5 times 6 is 5 groups of 6 equals 30. But it seems weird to understand how negative 5 times a negative 6 somehow is also positive 30. And like I said, sort of think about it as this one means opposite of, and this means groups of. Okay, and it can help you understand that. So if I look at it like this, 5 groups of negative 6, well, you know that would be a negative 30, but we have that opposite of out front. So the opposite of 5 groups of negative 6, well, if 5 times negative 6 is negative 30, opposite of that would have to be 30. And so that's sort of how you can think about that for it to make some conceptual sense. But let's also look at some patterns. A lot of times in math, we look at patterns to figure things out. So we knew that 2 groups of negative 3 is negative 9, because we love to hate, so we hate at the end. 1 group of negative 3 is, not negative 9. 2 groups of negative 3, 2 groups of negative 3 is negative 6, sorry. And 1 group of negative 3 is negative 3. 0 groups of negative 3 is 0. So look at the pattern. We have negative 6, negative 3, 0. So think about pattern-wise what this next one would have to be. Okay, now we have negative 1 groups of negative 3, or opposite of 1 times negative 3. Here's our 3. Negative 2 times negative 3 is 6. So you can see the pattern there. So a lot of times we figure out mathematics by looking at patterns as well. Okay, all right, let's go ahead and do example 3, multiplying integers with the same sign. Okay, so this is like saying 8 groups of negative 9, but what's the opposite of those? Or we can do our trick. So now we have I hate to hate, because negative means hate. So if you hate to hate, well, what's that mean? That means you actually love at the end. So 9 times 8 is 72, and there's my answer. Okay, so go ahead and check this one. You can pause if you want or follow along. So negative 5 times negative 13, I hate to hate. So that means I actually love. And so we have 5 times 13, and we have a positive 65. Okay, that's like saying what's the opposite of 5 groups of negative 13. All right, let's go ahead and do some substitutions. So we have the expression xy, okay, and I have to substitute x is negative 14, parentheses for organization, and y is negative 7. Okay, so I have I hate to hate, two negatives. That means I actually love. Love is positive, and 14 times 7 is 98. There we go. All right, let's try it over here. So we have PQ, and P is negative 16, and Q is negative 7. So I have a negative times a negative. That's I hate to hate. That means I actually love. And 16 times 7 is 112. And there you go. All right. Multiply 3 or more. Order of operations says we move from left to right. But if it's all multiplication, commutative property allows you to move it around anyway. But we're still going to follow order of operations and just move left to right. So remember, our trick for this is to underline what you're going to do for organizational purposes. So I hate to hate, so that means I actually love. 4 times 7 is 28. And then bring down your leftovers. Okay. Now we're going to solve this. 28 times a negative 2. I love to hate, so I actually hate. So I'm going to put my negative right away. Double 28, we're looking at 56. I double check it anyway, and it's negative because we love to hate, so we actually hate. That's like saying 28 groups of negative 2. And so there we go with negative 56. Let's go ahead and check it. Okay, so you can pause if you want to try this one on your own. I'm going to do the first two first. It's a hate to hate, so I actually love. So it's a positive here. 3 times 11 is 33. Bring down your leftovers. So now we have a positive times a negative. So that's I love to hate, which means I actually hate. So we have 99. 33 times 3. Just double checking. Okay, and we have a negative 99 because we have a positive times a negative makes a negative. All right, so just a review of order of operations. In 6th grade, you probably learned about PEMDAS. Okay, please excuse my dear Aunt Sally. P being parentheses or punctuation. E is exponents. M and D are multiplication division, whichever come first, though, from left to right. And AS is addition subtraction, whichever comes first from left to right. Okay, we're going to tweak it a little bit, and I want to introduce to you GermDOS. Okay, because really, it's not parentheses, it's not just punctuation, it really is a whole bunch of grouping symbols that you're going to come across. So anytime you see parentheses or brackets, absolute values are grouping. A radical sign, which is like a square root. Okay, you have to do things in there first. A vinculum, which is the fraction bar separating the numerator and denominator, you have to take care of all the stuff in the numerator before you would do things to it with the denominator, things like that. So all those are grouping that we need to be aware of. Now that you're getting into algebra, you also have to be aware of exponents and roots a little bit more. And that's something that would happen before the multiplication division or addition subtraction. So just to be aware of those order of operations, we actually need to be aware of it for this one because we have an exponents. Okay, so we're substituting. I would recommend as we get more complicated to actually write your expression out again and then go ahead and start substituting. So we have A is negative 5. Okay, I'm actually going to put this in parentheses. B is 4. So I'm going to put my parentheses here and do my 4. And then close your parentheses and make sure you put the square above that because it is separate from the B. So if it was a negative 4, you'd have to realize that you're doing negative 4 times negative 4 in there. So it's really important to have your parentheses for the exponents. And then multiplying by C, which is negative 9. So you can see I'm using the parentheses as organizational parentheses. Okay, so order of operations says I have to take care of grouping. Well, there's no grouping. Those are just organizational parentheses. There are exponents or roots. So we can see the 4 squared. So I have to take care of that first. So I'm going to go ahead and do 4 times 4, which is 16. and then I'm going to bring everything else down. So I have my -5, and I have my -9. Okay, now we do multiplication division, whichever comes first from left to right. Okay, so I have multiplication right here, and I'm going to have to think about my multiplying integers rule. So negative and positive, I hate to love, so I actually hate. Okay, and 5 times 16 is -80. Bring down the other one, which is multiply -9. Make sure you don't lose the parentheses, actually make it look like -9. That wouldn't be good. Now I have a hate to hate. They're both negative. So 80 times 9. Hate to hate, I actually love. And we end up with 720 out of that whole thing. Okay, so let's go ahead and have you try this one. Go ahead and pause, and then you can check it with me. Okay, I'm going to do a rewrite here. P, Q, R, S. Okay, P is -7. Q is 15. R is 1. That'll be a nice easy one. And S is -2. Let's go ahead and solve these from left to right. We have a negative times a positive. I hate to love, so I actually hate. So 7 times 15 is 105, but negative. Go ahead and bring everything down. Okay, now we'll do the next one. 105 times 1. I hate to love, though, so it's negative. And so we have -105 times -2. And let's go ahead and finish that off. So that's a negative times a negative, which is a positive. I hate to hate. So 105 times 2 should be 210. And it's hate to hate, so actually love. And we end up with 210 as your final answer. Okay, so you can see how just careful you have to be. All right, this part, I don't really love this section here, but I'll talk through it real quick for you. It is good to be familiar with the properties. Additive inverse property, remember that just means the opposite. When you add, like if I had 4 and I add a -4, those are going to make 0. Okay, so that's what that one is. We talked about that before. Distributive property says that when you have a number outside of parentheses with addition, you can actually distribute that, and it's the same thing as turning it into A times B plus A times C. So that's distributive. Identity property, I always remember that identity sort of looks like a 1, okay, and that's just saying that when you multiply by 1, you get the same number. And then the multiplication property of 0 is obviously anything times 0 is 0. Okay, so let's just sort of explore that. We'll walk through this a little bit. First thing, obviously, showing the 2 times 0 equals 0, or the -2 times 0 equals 0. This one is representing the 0 property. So you can just write that. That's fine. Okay, or the multiplication property of 0. Okay. We do need to put of multiplication because 0 property of addition is different. So 0 property of multiplication. The next one is showing that this 0 just turned into this. And so why does this represent 0? Well, it represents 0 because of that additive inverse. You can do a +1 plus a -1, and that equals 0. So that's why this one is the additive inverse property. Okay, so we'll just list what that is right there. Okay, now that we have the additive inverse property, I would distribute the 2 out. Okay, so I'm going to switch colors here. I would show this move here. And this is representing the distributive property, okay, when you distribute out the -2, so now it looks like what it does next to it. Then you have this 2, when you distribute, you had a negative 2 times 1. Let's change colors. This right here, okay, you being able to solve that is the property of multiplying by 1 equals the same thing. So we can say multiplication identity property, and so we have that. Okay. Now the last part here is, let's do this, plus 2 plus 2. That's how you got this final thing, and that is called the addition property of equality. And that just says you can add the same to both sides, and everything will still be the same. Okay, and so you end up showing that this is true. You can see down here by working through those different properties to get to that point. Okay, so I just wanted to expose you to that. Don't worry about that too much for right now. All right, let's go ahead and take a look at your apply and move on to your practice then. So 2 farms begin the year with 1,500 of extra savings each in case they lose money at the year's end. The table shows the amount of money each farm earned, or revenue, and the amount of money each farm spent, or expenses, for 1 month. So what they're saying with those commas is they're saying the amount earned equals revenue, and then the farm spent are called expenses. So they're using those interrupters of commas to explain to you what the word revenue means and what the word expenses means. Okay. Pay attention that it is in 1 month. If these results are consistent with the revenue expenses for each month of the year, which farm will have enough savings to continue to operate for a whole year? So obviously that's 12 months, right? And how much will they have left over? So bummer, 2 parts. Okay, so I'm just walking through this with you. I haven't solved this myself either, so you can hear my thinking with it. So I know that they begin the year with 1,500 of extra savings. Let's go ahead and figure out where they're at with all these things. So we have revenue and expenses. You need to know what's positive and what's negative. So what they earn, remember up here, is revenue. So is that positive or negative? If you said positive, you're right. So revenue is positive, expenses is negative. So I'm just going to make a note in my table. I'm also going to go ahead and label my numbers appropriately. So now I have all the negatives, the revenue are positive. I'll leave it invisible positive math. All right, so basically we have all these things to calculate up. So let's get our total of expenses and revenue and sort of see where we're at with things. Okay, so we're going to add up all this stuff. If we have all these negatives, we're just adding up negatives. Okay, and so we have 134 plus another 44 plus 152. Okay, so this section here, let's go ahead and I'm trying to think how I want to represent this. So I have negative $330 here, and I have a positive 308 here. So let's go ahead and join those together. So I have 308 plus a negative 330. Okay. So same signs add and keep, different signs subtract, 330 minus 308. And we're left with a, keep the sign of the bigger, we're actually at a negative $22 for farm 1. And let's go ahead and calculate farm 2. So add up all the expenses, all the negatives. Okay, so negatives, we have negative 386, so 476 positive, plus a negative 386, different sign subtract, 476 minus 386. Keep the sign of the bigger number, so it's positive. So we have a positive $90 here. Okay. Now farm 1 and farm 2, there's our remaining amounts after all revenues and expenses. It says which farm will have enough savings to continue to operate for the whole year and how much will they have left over. So they both, remember, began the year with $1,500 savings, but we need to realize a couple things here. So let's slow down for a second. The table shows the amount of money for 1 month, okay? So this is 1 month here equals 1 month. We're talking about the 2 farms begin a year with this much money, okay? So let's go ahead. We need to calculate how much is earned or lost over a 12-month period then. So let's go ahead and take our negative 22 times 12 months, and we have our 90 times 12 months. I'm going to just do the parentheses instead. Okay, so I hate to love, which means I actually hate. I know my ending amount is going to be negative. I love to love, we're going to be positive. So let's do our 22 times 12. So we're at a negative $264. Okay, that's sad. Okay, and then we have 90 times 12 is $1,080. Okay, so here's our 2 amounts now. Okay, and this is for 12 months or 1 year. So let's go ahead and see where we're at now. Okay, so we have $1,500 of extra savings. So let's go ahead and do our 1,500 plus that negative, and our 1,500 plus that positive, and let's see where we're at now. Minus 264. All right, so we're at 1,236 for this farm, and 1,500 plus 1,080. We're at $2,580 for farm 2. So going back to the question, which farm will have enough savings to continue to operate for the whole year? Well, it looks like both will have enough to operate. How much will they have left over? So let's go ahead and try to answer our question here. They both will have enough money. Farm A will have 1,236, and farm B will have 2,580. Okay, so it looks like they should be able to be good for the year and continue to operate with that extra money. Now, obviously, if farm A didn't have extra money, it would not be able to function. So there's our answer. All right, let's go ahead and try this check here. So James started a lawn care business in his community. He thinks that he should be able to operate his business for 20 weeks before it gets too cold. This shows the table shows 1 week. So obviously we're going to be multiplying it by 20. The table is 1 week only. We know what expenses are and revenue, right? So expenses are negatives, revenues are positives. So let's go ahead and represent those in the table. So let's go ahead and find out how much he's earning in 1 week and then multiply it by the 20 weeks. So add up all your negatives. So we have 32 plus 12 plus 17. oops, 32 plus 12. Always good to look at your calculator and see what it actually says. There we go. So we have this section is negative $61 in expenses plus the revenue. So 125. And then we're adding a negative. So different sign subtract. So just subtract 61. Okay, keep the sign of the bigger. And so it looks like we have a total, we're at $64 positive. And then multiply that by 20 weeks. 64 times 20, and, ooh, pretty nice. So after 20 weeks, we'll have $1,280 of profit, which will be really nice. Okay, so what money will he earn in 2 weeks? He will earn that much in 2 weeks. Pretty good deal. All right, let's go ahead to your practice and homework. Okay, so now we're going to really crank through these, try to get some fluency going. Okay, so 4 positive times a negative. I love to hate, so I actually hate 28. It rhymes. All right, I hate to hate, so I actually love. 6 times 8 is 48. All right, next one. I love to hate, which means you actually hate. I'm going to show which part I'm doing. So I have a negative 35. Bring down the rest. And now I hate to love. If you don't like loving, that means you hate. And so we have 35 times 4 is 140 negatives, because I have 4 groups of negative 35. All right, let's do this triple one here. Okay, underline the part of the problem you're going to do. I hate to hate, so I actually love. So 7 times 8 is 56. And then multiply by 3. 56 times 3 is 168. So there's multiplying integers. So you can do those other ones on your own. Let's go ahead and do some substitutions and evaluate the expression. So I have A times B. A is negative 16. B is negative 5. I hate to hate, so I actually love. 16 times 5 is 80. Okay. All right, let's try this one. I'm so glad that you're getting to see this one with me. It's really important. So we have x times y times z that is squared. Okay, so put everything in precisely. The x is negative 2. The y is 7. What is the z? The z is negative 4, and then that whole thing is squared. So it's really important to notice I put the whole z in parentheses. Okay, order of operations, GERMDAS, says I need to do exponents before anything else. So let's go ahead and take care of the exponents. This right here, just to be clear, is negative 4 times negative 4, because the whole z is getting squared. So 4 times 4 is 16. Because I hate to hate, I actually love. It's like saying the opposite of 4 times 4 groups of negative 4. All right, bring everything else down now. So we have my 7. I just like work my way over, being really careful. All right, now we're going to go ahead and do the next step, which is working from left to right. Okay, so negative 2 times 7. I hate to love. If I hate loving, I actually hate. 2 times 7 is 14. Bring down the 16. And now we'll finish it off. I hate to love, so I actually hate. And whatever 14 times 16 is, there's our answer, negative 224. Okay. All right, so you have the next one to do on the right as well. All right, let's go ahead and do our apply. It's the same thing we did in our notes. Okay, so let's look at the information. She thinks she could operate her lemonade business for 14 weeks. The table shows expenses and revenue for 1 week. Based on this, how much money will she make during the 14 weeks? All right, so let's go ahead and find out what all the expenses are. Okay, remember expenses are negatives, revenues are positive. So we have negatives, cups, lemonade, ice. So let's add all that up. We have 11 plus 7, 18. I don't want to do all this work and make mistakes, so I'm going to double check. Okay, yep, we're good. All right, so we're at $18 in expenses, but that's a negative $18. Okay, and then the positive 45. So if I join those together and add them, I have negative 18 plus 45. Same signs, add and keep, different signs subtract. 48 minus 18 is keep the sign of the bigger number. All right, so revenue of $30. Okay. This, though, is what, per 1 week. So per 1 week, there's my unit rate. Okay. The question is, well, what about for 14 weeks? So let's go over here. So we have 30 times 14. And what is 30 times 14? Okay, so she will make $420. Pretty good deal. I like it. Good lemonade business. All right, Rakeem's goal is to have at least $500 in his checking account at the end of the year. This table shows his activity for the month of January. That's 1 month. Will he make his goal if the month of January's activity is representative of how much he'll save and spend each month? Okay, so a debit card purchase, okay, that's a negative. A withdrawal is a negative, and a deposit is going in. So go ahead and you just need to calculate that and say if you agree that he'll have at least $500 in his checking account. If this is true, because whatever you get here as a final answer, okay, remember that this is per month, okay? And so you need to figure out, because that's just January, you need to figure out after a whole year, will he have at least $500 in his checking account or not? So that's for you to finish up. All right, go ahead and work on that. Let me know if you have any questions.